This is a flip video about boiling point elevation. So let's start with a substance that we're very familiar with, and that is pure water. You should know by now that pure water boils at about 100 degrees Celsius. Now, if you don't have pure water, so here's our pure water. If you don't have pure water, then you have some sort of a solute in it, seen here by the green spheres. That solute does something to the boiling point of water. No longer is that solvent's boiling point 100 degrees Celsius. Instead, adding some solute to a solvent causes that solvent to boil at a higher temperature. So water no longer boils at 100, instead it boils at a higher temperature. What is that higher temperature? Well, it depends how much solute you add. The more solute you add, the higher the temperature. Now, when I say the higher the temperature, I don't mean 120, 30, 40, 200 degrees Celsius. It's actually usually just 100.2, 0.3. So it's really kind of a push in the tenths place a lot of times. But obviously, if you do add a ton of solute, that could significantly start to impact the temperature. Okay, so to say it again, adding solute to a solvent raises the temperature at which it boils. Doesn't matter what the solvent is. So if your solvent normally boils at 50 degrees Celsius, and then you add any type of solute to it, it'll now raise higher than 50. So as the number of solute particles increase, the boiling point increases, as mentioned before. So we call this boiling point elevation because to elevate means to raise, kind of like an elevator. Now, in order to do calculations to see how much is the boiling point going to elevate, we need to first introduce three variables. So we've got KB, lowercase m, very important, not uppercase, and the letter I. My eyes are a little bit weird, but that's an I. Okay, KB is just a constant. It's just a constant. And a majority of the time, our solvent we talk about is water. So KB is usually going to be water's constant because, again, majority of the time we're talking about water as the solvent. And here is the constant, 0.51 degrees Celsius over little m, which we'll talk about what little m means. Okay? Next, little m. So little m stands for a new term, which is molality, not molarity. So be careful, little m, molality. Don't get it confused and don't write an uppercase M. Molality is just another way to talk about the concentration of a solution, except it is moles of solute over kilograms of solvent. This specific equation you will have to memorize. All right, and how about the last variable that we're going to need to know, the I? The I is actually pretty easy. It stands for ions. So it refers to the number of ions that come apart, that dissociate. So when we throw our solute in, it dissociates sometimes, right, if it's ionic. How many ions did it dissociate into? We'll have more examples on that coming up. Okay. Here's an example. Here is my solute, NaCl. It breaks into Na plus and Cl minus when I throw it into water, right? It dissociates into how many ions? 2. So therefore the I value is 2. 1, 2 ions. Let's try another one that's just a little bit more complicated. MgF2, another ionic compound, metal and a nonmetal. When when MgF2 is thrown into water, you get Mg2 plus and 2 of the F minus ions, right? 2 minuses to balance out the 2 plus. How many total ions is that? 1, 2, 3. 3 ions. That's an ion, that's an ion, that's an ion. Not how many charges there are, how many total ions. So my I is equal to 3. 3 ions dissociate. Okay? Now, what about when we talk about a compound that is being thrown in, a solute, that is not ionic, instead it is molecular? Remember, molecular is a compound that has nonmetals. Okay? Remember from last chapter, even though molecular compounds can dissolve in water, they don't break apart. So they do not dissociate. They stay intact, right? So with that being said, then your I is going to be equal to 1 because the entire molecule goes in and stays as one whole unit. So anytime you have a molecular compound, any molecular compound, your I is 1. That's something you should definitely memorize. Okay? Why did I need to know all 3 of these variables? Well, because we are now going to calculate, right, boiling point elevation, which is the whole point of this unit. Boiling point elevation. What's the equation? Well, let's look at it here. Change in TB, that stands for the change in temperature of the boiling point, equals KB, which we just said is the constant, M, molality, I, number of ions. So here's the equation. You multiply all 3 against each other. That's pretty easy. So how do we do that? Well, let's take a look at an example problem. I have 23.2 grams of MgCl2 and it dissolves in 175 grams of water. Now, right away, I know that solute is going to elevate. Any solute will elevate the boiling point, raise it, right? Water normally boils at 100, but guess what? Now with this MgCl2, it's going to boil at a higher boiling point. Remember, not a ton higher, but higher than 100. So what's this new boiling point? Remember, I used my equation. That's supposed to say I, made a little mistake. Okay? All right, I need my KB, I need my M, I need my I. Well, if you remember, my KB is just a constant, right? And that constant was that 0.51. So that one's easy to deal with. So let's move on then to the M, the M. How do I solve for M? Well, if you remember, M stands for molality. And molality is moles of solute over kilograms of solvent. Solvent. So moles of solute. Well, I have grams of solute, so I have to do a quick conversion. I start with my given 23.2 grams of solute and do the molar mass from the periodic table in 1 mole. With correct sig figs, I get 0.243 moles of MgCl2. That goes on top. How about my kilograms of solvent? Well, that's easy as well. My solvent is water. It's in grams. I just have to do a quick conversion, and if you remember, 1,000 grams in 1 kilogram, and there we go. Put them over each other, and I got 1.39 molal, or molality, not molarity. Okay, so I've got that piece. Now, going back to my problem, I still need to solve for I. If you remember, we're dealing with MgCl2. So let's take MgCl2 and dissociate it. I get Mg2 plus and 2 chloride ions for a total of 3. Now let's plug in all of these numbers and solve. So I just said my I is 3. I just did my molality, which is 1.39 lowercase m. And a second ago I had my constant, 0.51 degrees Celsius over m. Don't forget the units. That's a constant. We don't look at it. That's a counted number. We look at our measurement for sig figs. I have 3 sig figs. M cancels out with m. 3 has no unit on it because I counted. So I'm left with degrees Celsius. So let's multiply all 3 of these. Take a second and do that now. And round it to 3 sig figs. You should get 2.13 degrees Celsius. So is that the answer? Well, let's check the question. It asks, what's the boiling point of this solution? Well, That's how much it's elevated, right? It elevates up 2.13 degrees Celsius. But is that the boiling point of the new solution? No. If you remember, we said water has 100 degrees Celsius. When I add the solute, by the way, sig figs, when I add the solute, it elevated it to 2.13 degrees Celsius. So what's 100 plus the extra solute's elevation? 102 point, let's do sig figs, only one place after the decimal when we add versus 2. One place after the decimal is less, so I need one place after the decimal. There we go. That's the new temperature. Water starts off at 100, and when I added that much solute, it raised it up 2.13 degrees Celsius. There's the elevation. Put it together, 102.1 degrees Celsius is the new temperature. There you go. That's how you solve it. You should memorize the equation. You should memorize what molality is. You should memorize what I is. I will give you the KB.